recording. Hi everyone and welcome to our 14th episode. Today I'm really happy to welcome Dr. Annapurna. She's an associate professor of UPES Dehradun and her research focus is mostly on geosciences and energy exploration. Today she'll be discussing about her research and also showing some of her results. Then we, as usual, will also discuss a little bit about new technology and renewable energy, clean energy. So thanks, Annapurna, for being in the podcast. So happy to have you here.
Thank you so much. Thank you, Tanisha, for inviting me. So I really like to discuss on like presentations or maybe casual talk on geoscience, petroleum, and other energy opportunities.
Mm-hmm.
Thank you so much for inviting me.
No worries. So maybe we can start with a little bit of your research if you can talk about that in a broader sense. Then we can know a little bit about the data that you use in your research.
Okay. So basically, I'm a geoscientist. Earlier, I worked as geoscientist in a research organization, and currently, I'm working as associate professor at UPES Dehradun. So my career started as a geoscientist after my PhD. I started my career as a geoscientist where I used to do work on industrial data.
Mm-hmm.
Then I used to work on um, microbial data, petroleum exploration data from
Mm-hmm.
different organizations and industries like ONGC, GSPC, SR Oil. Then we received collaborative projects from um, Oilmax, Salon, most of the oil companies in
Mm-hmm.
this country. So during that time, I worked in many sedimentary basins like Cambe Basin,
Mm-hmm.
Assam Arakan Basin, then Krishna Godavari Basin, Indonesia, one basin from Indonesia also. I
Mm-hmm.
worked their data. Then as my PhD work, I worked in Raniganj Basin, South
Mm-hmm.
Karanpura. So my PhD work was on shale gas exploration.
Mm-hmm.
So at that time, actually, it was just started. In India, it was shale gas exploration was at very initial stage. Till
Uh-huh.
now, we are not doing much commercial exploration, but that time it was a very initial stage. So it was not so easy to get data. So I had to explore on the conventional data for unconventional shale gas exploration.
Mm-hmm.
So I visited field in different areas of Jharkhand and West Bengal, like Raniganj, South Karanpura, North Karanpura. So it was not so easy to explore new thing, unconventional shale gas areas in those remote areas.
Mm-hmm.
So, but I got a lot of support from my friends, those who worked in different industries like Coal India, then
Mm-hmm.
professionals, industry experts from ONGC. That time, ONGC started their pilot project at shale gas at Raniganj. So
Mm-hmm.
I got to collaborate with industry stalwarts. So it was very encouraging thing for me, and
Mm-hmm.
I got a lot of experience. It was not only technical experience. I learned a
Mm-hmm.
lot personal. I got so many personal experiences also that time.
Mm-hmm.
So it was not so easy to do something new. Uh, so, but I tried to work on some advanced technique which was not already implemented in Indian context, um, like Barnett shales, US shale gas reserves, where there are a lot of studies on Barnett shales and other shale gas reservoirs in USA. So I explored whatever the literature and what are the works they are doing. So I
Mm-hmm.
explore all the works and I try to do something new.
Yeah.
So after
Mm-hmm.
that, I started my career at Gujarat Energy Research and Management Institute. There, I worked on the industrial data, as I told you,
Mm-hmm.
from most of the oil companies in India. Then I shifted my career from research to teaching.
Mm-hmm.
Although teaching, I'm a academician, but research is also one of the main component. So we do research, and I have research scholars who are currently working on carbon sequestrations,
Mm-hmm.
geosequestrations, then CO2 sequestration for CBM recovery, enhanced oil recovery from coal beds, CO2 geostorage in shale rocks.
Mm-hmm.
Then one of my researcher recently she had joined for she will be working for different disasters and geological aspects in Himalayan regions.
Nice,
So these
nice.
are the current works.
Mm-hmm.
And, yeah, if I elaborate my research works, last year we actually one research on micro-seepage and macro-seepage analysis that I have initiated in 2019.
Mm-hmm.
Sorry, 2018, just before the COVID. We did
In
lot.
which area was this study?
It was in Assam.
Okay.
Assam, and it is in foothill of Himalayan region, north bank of Brahmaputra.
Mm-hmm.
This is an unexplored area. There is no that area is not under any oil company, but
Hmm.
there are some indications of hydrocarbon. So based
Okay.
on those indications, I visited those areas. Then many times I visited. Then my team, my research scholars team and me, we visited almost 10 villages. We have collected samples from almost 10 remote villages. We
Mm-hmm.
analyzed. It took 2 years to do all those research, but
Mm-hmm.
finally we got very encouraging outcome.
Oh,
So
okay.
we have identified a new hydrocarbon prospect.
Wow. That's great. Yeah.
No company is taking interest. No company was taking interest for those area because on the southern part is explored in Assam Arakan Basin. Northern part is it was not explored much. But we have identified that is there is hydrocarbon. So after that, I was invited for many workshops and conferences also, and I found that industries are taking interest for those areas also.
Hmm.
I got invitation from industry also to explain and about the outcome,
Yeah.
and they also took exact location where is the hydrocarbon. Then after that, after my study, they visited based on that outcome. They visited industry visited those areas. They also repeat the research. They did some experiment and then found that yes. Uh, that area has future prospect for hydrocarbon. So that
Hmm.
was very encouraging thing for me, and I feel really happy that because that area is very remote area and economically very backward. So if
Hmm.
our industry will take interest and
Yeah.
they explore that area, and if really they get a commercial amount of hydrocarbon, because in
Okay.
my research I have identified the prospect area, but
Mm-hmm.
how much it is commercial or not, that still I am not able to quantify because
Mm-hmm.
there is limitation of data.
Yeah.
Not much work has done. This was the first work in that area. So I'm not able to quantify. So if industry take interest, they do some wildcat drilling or they do some exploratory well drilling. If there is huge hydrocarbon reserve, then that area will be very, it will be very helpful for that reason.
Yeah.
So
Yeah. Of
think
course.
about economic development of that area.
And which publication was this? Maybe I'll post it also when yeah, after the talk.
Okay, yeah, that was published in one Nature publisher journal, Nature
Mm-hmm.
Scientific Report.
Okay. Great. So you talk about a lot of data. I mean, what is the nature of this data? What like for
Just
microseepage, for example, what
just give me
data?
a minute. I'd like to share you that paper.
Mm-hmm.
So let me share it. Can you please make me host here?
Yeah, I'm just trying to do it. think you should be able to share now.
So this was based on macro-seepage based potential new hydrocarbon prospect in Assam Arakan region. Actually, there
Yeah.
are few areas where macro-seepage means hydrocarbon is seeping and which is visible. So in this area, in northern bank of Brahmaputra in Assam, there is one area where it is gas is coming out since last 7 years. And there are some areas where before 3 years when we have started the work, so many areas gas started seeping and people are using it for their household work, cooking purpose.
Oh, okay.
Yeah, gas is naturally coming. So while they are trying to dig for the water pump, so gas started coming and they're using for their household purpose. They're using directly for cooking purpose. So we, based on those macro seepages, we have done micro seepage analysis also. So here I'm showing one location where gas, you can see this is natural gas coming out, naturally coming out from the subsurface, and people are using it for cooking. We have done macro seepage analysis, which is visible, where gas is already seeping, and based on that, surrounding this area, we have done for 100 square kilometer area macro seepage also. Because if there are some hydrocarbon under the subsurface, then the soils which are present just above the hydrocarbon, they also show some indications.
Oh, the soil shows indication, I see.
Yes.
Okay.
Generally, we do study rocks for source, like source rock where hydrocarbon generates. The reservoir rock where the hydrocarbon get accumulate. Actually, we study the hard sedimentary rocks. Okay, but soils also show some indications when there is hydrocarbon under the subsurface. And if there is some microfractures or fault connected to the hydrocarbon source or reservoir to the surface, then we can get it as macro seepage. So hydrocarbon can leakage.
Okay.
Fault via fault or fractures. So here also we have done some micro seepage analysis, which are covering almost 10 villages. So these are some results, like we have done methane, ethane, propane, butane. In these studies, only few locations where we have seen ethane, propane, but otherwise most of the gases are methane, light gases. So this may be biogenic, but there are some areas where we got indication of thermogenic gases also.
Okay. Okay.
So these maps are plotted for the whole, covering whole area, 100 square kilometer area, and it is showing that here the red color, these areas are having high anomalies, like high concentration. So when we do a huge area and we analyzed in the laboratory, we have done extensive laboratory works. Then results are plotted like maps, contour maps, and we have analyzed the anomalies. And we found that there are many interesting things we found here. There are thermogenic gases, as well as we have done some microbial analysis also. So here microbial analysis means if there is hydrocarbon under the subsurface, then hydrocarbon started seeping through the soils, through the fractures. Then some microbes develop there to eat the methane.
Oh.
So they are methane eating bacteria.
Okay.
Yeah. So when there are some microbes, so what we can get positive anomalies as well as we can get negative anomalies also. But it indicates something different when there is hydrocarbon. Sometimes we can get high concentration of microbe, and sometimes we can get negative microbes also based on the concentration of hydrocarbon.
Okay.
So we have done carbon isotope analysis also, and based on that, we found that yes, that area has hydrocarbon prospect. So that area can attract industries.
Sorry, that Annapurna, what was that image about? The earlier one? Not this. Yeah, here, this one is, what analysis is this?
Okay, so here we have done atomic adsorption spectroscopy analysis for trace elements. Trace elements like
Okay.
nickel, calcium,
Mm-hmm.
vanadium.
Mm-hmm.
We have analyzed 12 trace elements, and they also show some anomalies. Some elements like vanadium, thorium, they may show high concentration when there is hydrocarbon under the subsurface,
Okay.
and some element show some negative anomalies. So here,
Okay.
basically, we have done some anomaly studies.
Mm-hmm.
It is positive or negative, and then we overlap all the trace element results.
Okay.
And based on that, we find out that yes, there is one lineaments, and there is one pathway through which the hydrocarbon is coming, not exactly from below that area. It is coming from nearby area towards the Himalayan region. So it is
Mm.
not coming from or the conventional or maybe traditional the source rock, which is the traditional petroleum system, which is giving hydrocarbon in the southern part of Assam Arakan Basin. This is not the
Okay.
same. This is coming from this is coming towards Himalayan side.
Mm. I see.
And
Okay.
that area is very highly faulted area.
Mm-hmm.
Uh, so here, yes. So this image you can see here we have
Yeah.
drawn the pathway from where it is coming exactly. It is coming towards Himalayan foothill site, and if you go towards Himalaya, 15 kilometer, just 15 kilometer away from this area, there is one fault. Um, MBT fault is also 30 kilometer away. MBT fault is also there.
Mm-hmm.
That is uh, main boundary thrust fault.
I
So
see.
this area is near to faulted area where subsurface rocks are faulted. Uh, there are so many faults. So those faults are actually coming, working as the pathway through which the hydrocarbon is coming towards this site.
Mm. Okay. I see. Interesting. So now the oil and gas companies are looking in this area right now then to make it more,
Yes, after
yeah,
this
okay.
outcome, after this outcome, they approach for exactly in which area there is hydrocarbon indication. I shared with we had discussion with company, and uh, they have also tested in they have visited those locations and they tested it, then they found it, and again they approached me for further work. So still we are working.
Okay, great. And I see you did some unsupervised clusterings here, sorry.
Oh
So,
yes,
yes.
so
Oh,
it's
okay.
so yeah. Here also we have used this thing supervised and unsupervised clusters.
Oh, okay.
This is for trace elements.
Uh-huh.
Uh, so which respect to different trace element anomalies, we have to demarcate the boundaries of each trace element and how they are collaborating with each other, how
Mm-hmm.
they are operating with each other. To see all these results, we have done this class. We have done this cluster map for trace elements.
Okay. Okay. Yeah, it's really interesting. I hope that it does go into much bigger project. Yeah. It's, so,
And this project took time actually, and still I can remember as you asked me, you shared one question like um, day-to-day life of a geoscientist, or like
yeah, you're right.
as a
Yeah.
woman researcher. This project actually, when I have started this project, my son was 3 years old,
Mm-hmm.
3 years old that time. He was very small kid, and it was not easy for me to do all these surveys. It took many days to complete
Uh-huh.
this survey. So it was not easy for me. I can still remember those days when he also I took him to all these places, and
Oh, you had to take him? Oh my God.
yes,
Wow.
because he was very small and it was not in that area. He was not familiar to that area. We stay in Dehradun, and it was, although Assam is my home place, home
Mm-hmm.
state, but for him it was a different environment. So no one in those remote areas, no one is there to manage him. So I took him along with me all those in all those areas, and he enjoyed actually.
That's
Uh,
nice. That's really
I
good
scared
that
that
you got
how to,
exposed.
yeah, I scared how to manage with him with all those areas, because there is nothing. Tea gardens are there, and
Yeah.
most of the areas are field, then rivers. Okay, there was some areas are villages, covered villages, but other
Mm-hmm.
areas are like tea gardens. So I scared to take him, but he enjoyed that environment.
Wow, such a work-life balance you have to make. No, that's difficult for sure. And I hope that this definitely goes more into more commercial. So, Annapurna, you did mention about your other projects that include CCS with you. I would like to know a little bit more about it, maybe like a high level, but what do you see the future of this, or maybe what is your research direction in this? I'd like to know. Yeah,
So you are asking about the current research, or
yeah, the current research you are working on, and your opinion in general. Like, we don't want to go into more technical here, but just a high level, maybe. I know.
okay, okay. So currently we are working on mainly me and my research team is
It's
focusing on
11 o'clock.
carbon geosequestration.
Mm-hmm.
So along with the unconventional reservoir exploration, we are working on mainly focusing on carbon geosequestration.
Mm-hmm.
So nowadays we can hear the word like energy transition,
Yeah.
digitalization. Yeah, so here we can say that energy we are completely shifting from fossil fuel to something else.
Mm-hmm.
But we are also working on digitalization. And when we see that our energy revolution,
Mm-hmm.
that primitive human they used firewood, cow dung for like a source of energy, right?
Mm-hmm.
So with the time has been changed, and we have now a lot of energy options. After those all primitive things, we energy transformed. Then we have started using fossil fuels, coal, then oil, then natural gas. Then we are started using the unconventional natural gas, shale gas, coal bed methane,
Yeah.
all this. Yeah.
Uh-huh.
So if you see the energy revolution, energy history, energy
Mm-hmm.
sources are increasing day by day. Energy sources are increasing. With the increasing technology, now we are equipped to explore other energies also, other than
Mm-hmm.
these conventional energies like solar energy, then wind energy, tide energy. So
Mm-hmm.
what I think in future, um, we will get lot of options, opportunities for other energy resources also.
Mm-hmm.
But we also have the huge amount of hydrocarbon prospects in our Indian basins. There are a lot of unexplored area which are
Mm-hmm.
yet to explore. So we have tremendous resources for hydrocarbon.
Mm-hmm.
We have tremendous hydrocarbon resources in Indian sedimentary fields. So currently, I am working for unconventional natural gas exploration, because these are comparatively cleaner. Natural gas is cleaner than coal or
Mm-hmm.
other fossil fuels. Then we are working for oil and gas enhanced oil recovery using the CO2.
Mm-hmm.
CO2 enhanced oil recovery, CO2 enhanced gas recovery. So
Mm-hmm.
where the CO2 will be used for not only storage purpose, sequestration purpose, or permanent
Mm-hmm.
storage purpose, it will be used for enhance the oil and gas recovery also.
Hmm.
So recently we published, one of my research scholars, he has published a paper on CO2 storage, permanent storage in shale formations.
Mm-hmm.
Then another one is working on CO2 and hence gas recovery from coal beds.
Hmm.
So
Okay.
we are working on absorbed gas amount, how much absorbed gas, how much gas can be absorbed, what is the
Hmm.
storage capacity of free gas as well as absorbed gas. So
Hmm.
these things we are doing. We are doing a lot of laboratory investigations, absorption analysis, then how the gas storage capacity is controlled by um, mineralogy,
Mm-hmm.
then rock mechanics, then depth, pressure. There are so many controlling parameters. So
Yeah.
we are evaluating all those controlling parameter for the specific shales, carbonates, then coals, and then how these parameters are. We are trying to understand the statistical relationship among those parameters.
Mm-hmm.
Then we have done also simulation studies to
Mm-hmm.
understand what is the storage capacity and what is the we are trying to predict how much
Mm-hmm.
gas or oil can be recovered, additional oil or gas can be recovered for after CO2 injection.
I
So
see.
these kind of studies we are doing, and my research team have developed one um, lab also for CO2 geosequestration.
Okay. I see.
Still,
Great.
we are
Great.
working on
No, of
improving
course you
our
will.
data. Yeah.
You'll definitely develop that. Yeah, it's a very good insight. Like nice to good to know about all these new technologies that's developing. Yeah, I mean, I think we did had a really good discussion. Really looking forward that you develop the micro-seepage was really exciting. Like I hope that this gets bigger and then more economic. And thanks, Annapurna, for sharing your presentation, like your research and your all insights are really helpful. And hope our viewers like this podcast. Thanks so much, Annapurna.
Thank you. Thank you.